There you are now. Welcome back to the garage. So today's episode we have the engine dressed and it is ready to go back in the GT race car. First order of operations is to get the GT jacked up and then the engine in the engine crane. Now, just before I put the engine in, one of the things I like to do is just to get the filter changed out. That's the original filter that's in it. So I've pre-filled this filter and you'll notice these are a much bigger, much deeper filter. I've just found these in the last short while. So that's the kind of OC21 from, Mal or Wix that we most commonly use. This is a new filter. I'm going to give you the number of it. It's WL7077 from Wix Filters. And you can see it's a much deeper filter with much more space, but it also has a magnet in the base of it, which the old original Unipart filters used to have and had gone completely. I haven't found them in a long time until I was down at my local auto factors who were really nice people and let me rummage around their shelves to see different filters and different styles of filters. And I found this filter there, which, as you can see, much bigger filter surface area, so a nice job. Last thing to do is to put in the oil drain bung and then we can start dropping the engine in. So the first thing to do is obviously just to get this lowered in. You've got to take your time with this. Given that this is the Clubman front end, it just makes it a good bit easier. There's loads of space. You can put the engine in pretty much fully dressed. I leave off the radiator and I have the exhaust manifold out because it's just, I find it much easier, in a race car like this where an engine has to come in and out. You've got to have a way of getting the engine in and out quickly. And every kind of facet of this build, when I built this car, that's exactly what I thought about. I thought about how I could easily get the engine in and out. For example, the alternator is a really tidy, compact, high capacity, small alternator that's swung in really tight to the block, just to make sure that I have as much room in the engine bay as I possibly can. The same happens with the starter motor. It is one of those compact high torque starter motors. It has lots and lots of space, lots and lots of room. And the more space you have in your engine bay, the easier it is going to be to get your engines in and out. And like I said, with race motors, they can do 20 hours pretty much before they have to come out and get tidied up. So it's not something that, it's not going to come as a surprise that the engine will have to come in and out regularly. So this has Cooper S drive shafts as is par for its age. And the nice thing about Cooper S drive shafts is you don't have to take off the wheel hubs like you would with pot joints in order to get them to sit in. You can just sit them into place here as you're dropping the engine in. It's 4 bolts and they sit in there nice and easily. So again, it's thinking about how to be able to easily get engines in and out quickly and the most efficiently that you can. Now what I do when I get very close here, I don't actually drop the engine fully down. I get it lined up with the bolts on this side. You'll see this is my own device. This is my own engine pickup hook, which I designed, well, it's probably about the 17th iteration, but I've had it now for a good long time. What it does is it holds the engine up nice and straight, but it also allows me to have the engine just ever so slightly canted over towards the radiator side. These are the easiest 2 bolts to get into the subframe mount, where the engine mount goes in the subframe. So I get these 2 bolts in and then I just let the engine drop into the other side. And then you can kind of hover it up and down and get those 2 bolts in. It's not easy, but this makes it probably the most straightforward it can be. People often ask me about the engine mounts that have the captive nuts in them. I've used them in the past, but I've never found them very successful because 2 problems. One, the captive nut itself tends to be quite soft. Now you can cut them off and replace them with good quality, grade 8.8 or even grade 10 nuts. But you have the problem whereby you have very limited space to get that bolt in. What I actually find is I run the bolt hole in the subframe and in the engine mount at 9 millimeters. and the bolt is only 8mm diameter shank. So that gives you 1mm of play to move around. Is there any problem with not having that bolt dead tight? No, because in an engine like a race engine like this, it has solid engine steadies, 2 on the gearbox and 1 up here on the top of the engine block. So there's no problem with having that little bit of extra play in the engine mounting bolts, just getting it to line up and sit in, and it makes it much easier to get the bolts in. Once I have those bolts in, we can let the crane off and then we can start dressing the engine in the bay. Okay, so we have the engine dropped in and we have the 4 bolts in the engine mount. Now it's time to start connecting up all the ancillaries to be able to make this engine spring into life. I have an order about which I always do this, and some people do it one way, some people do another. I like to start here at the clutch housing. I put on the slave cylinder, then I put the exhaust and inlet manifold on, then I put the radiator in and its piping, and then I do the electro at the front, so the alternator, the starter and the distributor. Then I do the oil feeds and then the engine mounting last. Top engine steady last, because it's nice to be able to have that movement in the engine while you're trying to work everything into place. Putting that in there last, then when you have everything in place, gives you the chance to kind of move stuff around and get it into the right position. The fasteners that I'm using again are these A2 stainless steel. Now, a couple of questions came up, a couple of people messaged me about these fasteners, and I want to just clarify. There's many different types of A2 stainless steel. A2 is just the classification. There's a number comes after it. 40 and 60 are the 2 most common types, and they're denoting the tensile strength of the stainless steel. These are actually 90 grade, so they're the next one on again, and all the fasteners I'm using are 90 grade, which are pretty much the highest quality, highest tensile stainless steel fastener you can get. Of course, with that comes great expense. Would I recommend 60? Here's the thing. A2-40 would be just slightly lower tensile strength than 8.8, which is the kind of common steel fastener, zinc coated steel fastener. So if your machine work had 8.8 bolts, then you would be reasonably safe replacing them with A2-40. If you wanted to be extra safe, you could get the A2-60, and that would mean that you had near 10.9. I think it's actually probably 10 would be the same tensile strength, or near that. I go all the way to the 90, and that would have the same tensile strength as 12.9. Is it overkill? It probably is, but on a race engine like this, there isn't that many fasteners, and for peace of mind to know that you have the strongest fastener you can have, it's just where I go. As I said, maybe a little bit overkill, but probably still worth it in the end. You'd probably get away with 60 in most cases, especially for stuff like this that is non-stress loading. It's only holding something in place, like a clutch like that. If you were going for something that was maybe stress loading, like a drive shaft or something like that, then in that case, yes, you'd be better off going for something like the 60 or the 90. Next to do after this then will be to get the exhaust put into place. The exhaust in this is a Maniflow exhaust. It is the full race LCB. I'm going to show you what that looks like. It's a bit different to the other sort of standard LCBs that you would be probably familiar with. It has a bit higher flow and a bit more, I suppose, finesse in the way it's produced or in the way it's put together. Here's a real good example now of why not having that top engine mount in place. I can get to turn this Allen key around by just pulling that engine forward and getting in there. Otherwise, I would have to use the Allen key, you know, at the 90 degrees, and it would have been tighter, hard to kind of get access there. I'll show you the exhaust now, and then we'll get that fitted. So this is the exhaust for the Race GT, and this is the sort of ultimate Maniflow exhaust that you can kind of get. It is the latest stage of it. It's a full system. It's not just about the exhaust manifold, but the manifold itself is quite different. So some of the nuances about this manifold are, if we look at how the center main is, it's much bigger and stouter here, and then it reduces down into the normal sort of 1.75 inch here. So it's almost 2-inch diameter up here, and you can see the swage that's formed in this is really nice and clean, and it allows for much better exhaust flow. This is for really big cams. This motor's run over 310 degrees duration, so it needs all the exhaust it can get. If we look at the outer cylinders, you can see the same thing. These much cleaner lines. You can see it's made in 3 pieces here. So you have the first bend, the second bend, and then the Y piece where it joins. In the other types of, say for example, a normal LCB, this is actually a 1 piece. It's 1 piece, and then it would weld together here. So they've gone for just that extra bit of work. You can see the same on this side. It's still a 1-piece bend, but you can see where it's 2-piece in here. And that's all about getting more flow, getting the most flow possible. Is this something that you need for your Road 1380? No, to be honest with you, a normal LCB will get you where you need to be. In the application of this engine, we're just trying to squeeze every last horsepower we can out, and this is one of the places where there is some power to be found. Is it huge? Not necessarily. When I built this motor first, I ran it with a normal LCB, and then we changed to this. We actually seen a bigger increase in torque than we did horsepower going to this later style LCB. So we did see an increase in power, but definitely more horsepower. So that'll give you kind of an idea. Getting this into the car can be a little bit of a faff. What's required is just to gently tread it down inside there. So I always go with the 2 pipes first. And get that sort of sitting where it needs to be. Don't bother putting it in tight, because you're going to need to move it around. And then get the center branch in. So getting the center branch in then is just in alongside that one, down alongside the drive shaft, and in there. Now I made that look easy, didn't I? And it'll come back to bite me here. So this is, again lads, why I do say to you about leaving that manifold, or leaving that engine loose, because it just gives you room to kind of work around here and get that exhaust into place, to move it about and get that to sit into place. If you had that engine steady on there, it'd be a complete pain to try and get that to sit in where it is. Connecting it up underneath is just a simple case of using a copper hammer and just gently drifting the Y piece, the 2 exits from the Y piece, or sorry, the 2 exits from the manifold into the Y piece. Just nice and gentle with a copper hammer, hold it up and drift them together and tighten the clamps up on it. Okay, so the first thing to do is to get the gear linkage in place, because you've got that big long bolt that's a complete pain to get in if the exhaust is in place. So we get that in first, and it gives us room for our ratchet and our spanner. So these little small ratchets from Facom are absolutely the business. They fit into pretty much anywhere, and I think they're essential for working on a Mini. I think Snap-on or any of those brands probably do one as well, but I love this little Facom ratchet. Get this bolt done up. Yeah. There is a pin to go through this gear linkage, which we have to line up. That taps in there. This is much easier to do when you're not trying to film it. One little tap off the punch. Perfect. Now we can get our exhaust manifold arranged and get that white piece in there. It is a bit of a faff getting these exhaust pipes into place, but if you kind of just take your time with them and move them around. You will get them in there eventually. I have the exhaust box loosened off at the back so it can slide, and that's the way I normally do it. You get them to walk up in there. And then do up your bolts. The only other jobs to be done under here now will be to put the engine mounts on and connect to the drive shaft. But I don't do that until such a time as I have the rest of the top of the engine buttoned up, because as I said, it's nice to be able to move the engine around. Once you have those engine mountings in place, there's no moving this engine even a tiny little bit. Okay, let's look at getting the water system into place now. So now to put the radiator in, I led you a little astray earlier on. I said carburetors. I don't put the carburetors on this engine until the engine steady is in place. I do normally put the carbs on, but because this has split Webers on a big heavy manifold, I don't. I actually put the radiator in first and then the carbs. So get that rad bottom bolt in, which can be a little bit of a tricky one. As I said, it's handy if you can just move things around. And then you spin that up. Where this Facom ratchet is just the business. It has one of these little features whereby if you turn the handle, it ratchets the socket, which is unbelievably useful in a Mini. So many times it comes to great use. This top rad hose got a bit of a speckling of paint, I think, when we were doing our workshop renovations. Bowl boy Paul, I didn't cover that up properly. That'll be some cleaning for me to do this afternoon. Then we're going to put the hose on then, and then we'll put the top mount on. So the hose down this side, you'll remember from if you've seen the video we did on fitting the external or the auxiliary fan, there's a specific way to put the Jubilee clip. You want to have the Jubilee clip so it's accessible. Just run up this bolt. Okay, that one's run up. Now you'll notice something a bit unusual about the top of this radiator, I think. There's another hose that you might not have seen before. So that's a modification that I do on my race cars to promote cooling the far side of the cylinder head. So this hose here, a very good friend and pal of mine, Richie Redmond, soldered in a fitting into the top of this top tank for me. And it allows me to run a pipe across the top of the cylinder head and connect up over this side. What that does for me is it promotes water cooling off the back of the cylinder head and into the top of the rad. Some people, what they do is they run that hose across and into this pipe down here on the water pump, which would have been the original pipe that came from the internal radiator. This will pump hot water back into the water pump, which will pump straight back into the block. Great for a radiator where you want to get loads of heat into the car. Terrible for promoting cooling in a race engine. This setup where you take water off the top of the block and push it back into the top tank means that the only way that that water can get back to the water pump is to go down all the way through the rad, come out the bottom rad hose into the pump and back into the engine. So you're promoting cooling through the engine by doing that. You'll see this on some race cars and they won't tell you why they're doing it that way. I'm telling you, that's the job. Bring water, push it down through the rad, get it back through the water pump, get it into the engine. Okay, next thing to get on here is these 2 bolts that are going to hold on the top rad steady. And I think that is them here. So these 2 guys pop in through the thermostat housing. You'll notice there's an unusually big thermostat housing on this. That is on purpose, again, to try and promote water flow from the top of the cylinder head. This pipe you can buy from Mini Spares and it allows you to use this, I think it's Metro maybe. I think it's a Metro top thermostat housing, but they're available on Mini Spares or any of the big mini part suppliers. Now, go get an Allen key for them. Okay, that's that oil line cooler on, or the cooler oil line on, should I say. With a link cable to put in here. And then the very next thing we have to do is to get the distributor set up. Then once we have the distributor set up, we can put the engine mounting into place. We can get the engine pressure fed with oil, and then we will be ready to install the carburetors, get some fuel pressure up, and we'll be ready to give this thing a swing over and see if it'll start. Carburetor time now. These carburetors are dialed onto the manifold with pins. So they have been set up, there's pins sticking out the back of the block mounting face that these carburetors sit onto, and that's how we know that they're central with the ports. So we don't have to worry about aligning them or anything. Once they sit on those dowel pins, we know we're in exactly the right position. We know where we need to be. I use the brass nuts with the big heavy washers for these because I find that with the heat that comes from the manifold, the brass tends to be more forgiving in not coming loose, basically. If you use steel nuts on there, 2 things happen. One, when you're trying to get them off again afterwards, they tend to be heat seized on. And second of all, I found that if you use steel nuts on there, you have to constantly keep checking them to make sure they're still up to torque spec or they're tight enough that they're at the right tension. So once we get these carbs buttoned down, we'll get fuel pressure up to the carbs. Then we're going to pre-lube the engine. I'll show you that process. And then once the engine's pre-lubed, then it'll be ready for us to swing it over and see if we can get it to start. We have the carburetors on now. We brought fuel pressure up. The last thing to do before we're going to start the engine is to bring oil pressure up in the engine. I always do this in a race engine. This is a rig that I've made up, and you guys are getting used to me making fabric hobbling schmozzles. So this is an old carbon dioxide fire extinguisher that I have drilled and tapped a hole in the side of it here for an airline fitting. So that's my airline from the workshop is coming in here. The fire extinguisher is full of 2050 engine oil, and coming out of the outlet of the fire extinguisher is a hose barb. I connect this to the oil cooler, so it goes from the oil cooler through the oil filter into the main pressure galleries of the engine. What I can then do by depressing this lever is I can put whatever pressure I like. I have the compressor at 50 pounds per square inch now. So by depressing this lever, I'm pumping oil into the engine at 50 pounds per square inch. We're going to show you that now, and you're going to see the pressure coming up on the oil pressure gauge. Okay, so as you can see, the oil pressure gauge is at 0. I'm going to depress the lever here now, which is going to pump oil into the engine, and you should see the oil pressure gauge rising up. Okay, so what that means now is we have oil pressure in the engine. Next thing we're going to do is we're going to swing it over and see if we can get this puppy to fire. Well, I think that's a success. I don't mind a little bit of smoke. Alrighty guys, so that kind of brings our video hopefully to a conclusion. Hopefully you enjoyed us taking that motor from what was a problem child with an obvious broken center main bearing. Then we went through, and on the channel this is all there for anybody who wants to see this. We set ourselves up in-house to line bore the engine block to fit a 4-bolt center main strap. We took it from there and with you guys brought you all the way along through rebuilding the motor, putting the motor back together, and then on this episode putting it in the car and getting the motor fired up. We have still a bit of work to do on the GT, and in future episodes as we go along you'll get to see the GT being made ready for this year. The plan will be now to go around the car and fix all the little bits and pieces that have come up between the last test session and little few problems that have happened over its last couple of races. So there'll be some interesting footage sprinkled in over the next few months, I suppose, of the car coming together. Hopefully you enjoyed it. I'm going to give a shout out now to a podcast that has been really good exponents of the channel here. Hopefully I'll do this justice now. The name of the podcast is Classic Mini Breakdown. He's a guy in the States and he has been really pushing our channel on his podcast. So thank you so very much for all of the information and for passing that on. We'll put a link down below in the description to that podcast. I've been binge listening to them over the last couple of weeks here in the garage, and I have to say it makes for very entertaining listening. He's a lovely guy and has some really cool guests on there with some interesting stories to tell. After that guys, thank you so much to everybody who's subscribed to the channel, to everybody who has been commenting along on all the engine build videos along the way. I've been getting some really lovely positive comments from people who are really appreciating me showing you tips and tricks. To that end guys, when I started this channel, my whole idea was to put out there in the real world how I as a mini mechanic have been innovating, creating and learning, so that you guys can make benefit of that. And that is my goal with this channel, is to give you that information. I don't hide anything. I have no interest in cloaks and daggers or putting, you know, shrouds of mystery around stuff. I want to put that information out there for you guys to help you, to allow you have access to the information I have access to. After that guys, thank you to anybody who is new to the channel for watching. I hope you enjoyed, and there's a wealth of information already on the channel, and it'll be increasing continually over the next few months and hopefully years. And after that, to anybody who is a new subscriber, if you to anybody who hasn't subscribed already to the channel and is watching this video, maybe give us a subscribe. It really does help. Anybody who has enjoyed the video and enjoyed the series, give us a thumbs up. That also helps our channel and helps it to grow. And please do comment in the comment section below. We have had a really interesting fun reading the comments from the very last video, where I alluded to the flywheel bolt being FT. Fabulously tight, I think, was one. Really flippin' tight, I think, was another one. Keep coming in with those ones. I love them. They're really cool, and maybe we might put one of those on a t-shirt over the next couple of weeks or months. But other than that guys, I'm rambling on now, so I'll move on and I will see you guys on the next one.